Start recording. Super. Okay, so this total term omega t plus phi is a phase. Now what was omega t? What is omega? What's omega? It is angular frequency.
Okay. So your voice keeps breaking.
Is my voice is breaking?
Yes,
Okay.
sir.
Let me check my network. Okay, let me just sit somewhere, maybe due to fan. This is clear now?
Yes, sir. Now it's clear.
Okay then. Okay. So what was T here?
Time.
Time period, and phi is? Phi is phase constant. See here?
Yes.
Phi is phase constant. Now, phase totally depends on time. Depends on time. So let's see some conditions, cases. Like when t is equal to 0, what will happen? T is half, t is 1, what will happen? Before that, let me draw a diagram for pendulum.
Okay, sir.
The value of phase at time t equals to 0 is termed as phase constant. This is string, this is Mr. Bob. So these are two extremes, one here and one on left side and one is the right side. Okay. So let's take a condition. Let x function of x is a function of t. X of t, let's write that. A cos omega t. Here we are considering phase constant as 0. Okay, so we are just initially it was at mean position. Now from here we are lifting it here and we are leaving from here. So this is our initial position now. Are you able to understand? See, it was its mean position. Now we lifted this ball, or we just pulled this ball, we applied force here and just stopped here. And we are leaving it here. From here we are leaving. So from here, this is your initial position. It moves here, come back here. So this is your one oscillation now. Okay, it will move here, come back to this point, that is your oscillation. And gradually it will keep decreasing and come to again to the original position. This is our case. Now we will take a point on those things. You understand what we are going to do?
Yes, sir.
Okay. So if you understand, then say yes. If you don't understand, say no. I don't mind saying it again, okay? Don't feel shy to say no.
Okay, sir.
Okay, so let's take it as mean position. Oh yeah, I forgot I here. Mean position. So mean position means t equals to 0. So if t equals to 0, what will happen to this equation? Let's take number 1. Say that what will happen to t equals to 0 position? Yeah. What we are doing, we are substituting t as 0. So what will happen to this equation?
A cos 0.
A cos 0. That means
A.
yes. That is A because cos 0 is 1.
1.
Okay. Now this second one, t equals to t by 4. Now what are this t by 4? What is it? See, omega 2 equals to 2 pi by t. Omega is 2 pi by t. So what we are studying, we are saying t equals to t by 4. Then next t equals to, it moved here, and again from here to here, then 1 point, then second point, then third point. So this is your first position, second position, and third position. Again to back, that is fourth position. Again to back, that is fifth position.
Sir, I didn't understand the positions.
Okay. Let me show you this one again. So from here to here, so now this is initial position we wrote here, t equals to 0. That is position number 1. So we are moving it back at t by 4. That is position number 2. T by 4, another t by 4 will give you t by 2. That is position number 3. This is t by 4. This one t by 4, back t by 4, and one more t by 4. Our initial position is this one. I'll make a red so that it is initial position. This is your initial starting point. Starting point means t equal to 0. Now we are starting. From 0 we are starting. That is t equals to 0. That is your first position. Understood? First position? T equals to 0. Initial. Their amplitude is A. If I say, just we are holding a pendulum and we are lifting a pendulum on the one side. Do I have anything to show? Oh no, I don't have anything. Okay, then how will I say? This pendulum, this is at a mean position, right? This is a mean position.
Yes, sir.
Now we are lifting this pendulum to this side. Whatever the position it is. We are lifting here till here. Now we are leaving from here. We lifted till here and we just left from here. We just leave this bob from here. So it started its motion. Till here we didn't lift. We are just holding it here. We hold it here. Holding point. Now we are leaving from here. That is initial position. So initial position we took as t equals to 0. Now we are starting at 0. So your 0th point amplitude is maximum. That is x equals to a. Now we are leaving it. So from this one, it came back to this point. That is t by 4. That is a position number 2. Again, it moved till here to its another extreme. That is third position, which is t by 4 plus t by 4, which is t by 2. Again, obviously, it will return back. It will not stop here. So it comes here to the mean position, that is fourth point, t by 2 plus t by 4, which will give you 3t by 4. Right? So this fourth point is 3t by 4. Again, add t by 4 to get this fifth position. What you will get? T. Will you get T?
Yes, sir.
Right. This is your fifth position. And same, it goes on. So that's what we are going to write about this. If you understood, you can start doing it. I'll solve it here. And you can check with me. Like you understood or not, you can try that. First point, t by 4, then t by 2, then next 3t by 4 we got, then we added. What was that next? After 3t by 4?
T.
T, yes. T equals to T. Then if we add one more position, it will be, I guess so, 5t by 4, if I'm not wrong. T by 4, T plus T by 4, 4, 5, yeah, 5t by 4, right?
Yes, sir.
It goes on. Okay, let's do this now. Second one, x equals to t by 4, which is a cos omega t by 4. Omega equals to 2 pi by t. A cos 2 pi by t into t by 4, t cancel, 2 cancel, so 90. So x equals to t by 4, which will give you how much? Cos 90 is?
0?
Exactly. Why you are doubtful?
No, sir. I get confused with this.
Sure. Third one. We saw this 2. This one done. So now 3t by 4. So if you want to know how we got this t by 4, it was t by 4 plus t by 2. No, next is t by 2, right? Wait. T by 4 we did, then next is t by 2. Yes, not t by 4. T by 4 plus t by 4, which will give you t by 2. X equals to t by 2, which is a cos 2 pi by t, t by 2. So what you will get here? Yes, Devanshika, you there?
T cancel, 2 cancel, cos 180 minus 1.
So a cos pi in radians, that is minus a.
Minus A.
Fourth, what's fourth position? Again add t by 4, which is 3t by 4. T equals to t by 2 plus t by 4, which is 3t by 4. X equals to 3t by 4. A cos, same thing we are doing, 2 pi by t 3t by 4 which is a cos 3 pi by 2. So how to make it 3 pi by 2? Cos 3 pi by 2 means cos 90 plus 180.
180.
Am I right? 3 into 180 by 2. 90, 270. Is it 270? Yes, correct. So it is similar to cos 90.
0.
Yeah, which is 0. Now last one, t equals to capital T. Try this. Try this.
A.
Okay, it should be A only. See, if we see logically, at t and 0, the both positions are same, right? T and 0, both positions are same. So we should get A. Let's write this. A cos omega t, A cos 2 pi by t, which is A. Let's make a tabular column of all these values and we can draw a graph. Okay, my lines are going cross. Okay. So T and displacement. When it was 0, so what are the values we got? So let's write this first T. We took 0, T by 4, then T by 2, 3, T by 4, 2, 3, 4, and last one T. So here it is A, this one also A. And T by 2 minus A. T by 4 and 3T by 4, 0 and 0. Okay, can you plot this graph? On y-axis, amplitude in short distance, x, and x-axis, time period, t. Draw a graph or plot a graph. Devanshika, when you have exam for physics exam or science, like, when is your exam starting? You said May something, oh sorry, March something, right?
Yes, it will start from April 20.
No, then whose exam is starting on March? Somebody said March. Maybe Varun.
So it may be like a monthly test.
Okay, because I remember like Varun said, I think so. Someone said. Okay. Have you plotted graph?
Sir, the X should be on
X should be means this initial distance should be on y-axis.
Y-axis.
So first is 0. Second one, t by 4. Third one, t by 2. Fourth one, 3t by 4. Fifth one, t. Oh, I made it so near. Okay, fine. Here, let's take it as minus a, and this one as plus a. So when t is 0, in short, we want 0, comma a. First one. Second one, we want t by 4, comma 0. Third one, we want t by 2, comma minus a. Fourth, 3t by 4, comma 0. And fifth, t, comma a. So how graph will go? Yes? Have you done drawing?
I'll do it.
Done? Okay. What about you, Devanshika?
Done, sir.
Done? So how what is the shape that you got? Is it square? Parabola? What is the shape? What is the shape?
It's a parabola.
Parabola, right?
Yes, sir.
And for this one, it's here. This one, it's here. And this one, I think so. Here. Okay, this might not be straight. Yeah. Oh, I got it. This is the shape you got, right?
Yes, sir. Same.
Okay, fine. So by this, what we are seeing, what we are able to see, what is the conclusion? Can you give me some conclusion? I want conclusion from both of you. So by this graph, what we are concluding? See the value and you can answer. Conclusion doesn't mean like a so big deal. Just see the values and conclude that. So what you understood? Yes? Let's start with Sai. Doesn't matter it's right or wrong. Just what you understood from this graph and like this table and what we did here, like these conditions.
Sir, I don't know how to like form it into words.
Like, see, go with the values. First one, what we did, we took 0. Then what happens? X equals to A. What does it mean? A is what? What is A? Scroll up and see that. Not scroll up, turn your pages and see that. What we wrote yesterday. What is A? A is amplitude, right? Okay, let me show you then. Where it went, yeah. See this? A is amplitude. So when time is 0, we are getting maximum. So which case it is maximum? At extremes, we are getting as maximum. When t equals to 0, we are getting x equals to A. And when we took t as t by 4, we are getting it 0. And when t is half, t by 2, we are getting negative value. Negative of maximum amplitude or maximum value in negative side. Same way, when we are taking t equals to t, again we are getting maximum value on positive side. That is what we are concluding. Understood? Conclusion doesn't mean so big deal. Just what you did, that's what we are saying in words. Here we wrote in tabular form and down we can write in words. Got it? You understood or not?
Understood.
Okay. What about you, Devanshika?
Yes, understood.
Okay. Then let's do about angular frequency. So angular frequency means angular displacement per unit time. That is, it is denoted a unit as radians per second. Unit as radians per second. So we know formula T equals to 1 by F or 1 by V. So we know omega value 2 pi by T. So 1 by T is frequency. So omega is 2 pi by frequency F or 2 pi V. In whatever, some book it's F, some book it is eta V. Okay. So yeah, we have time, right? Okay. So simple harmonic motion and uniform circular motion. So what do you mean by uniform? What do you mean by uniform?
Equal distances and equal intervals of time.
Yeah. And circular motion? What do you mean by circular motion? Name itself, motion in circular path. That is what we are going to discuss. A projection of uniform circular motion on a diameter of a circle flows or follows SHM, simple harmonic motion. What does it mean if I draw a path this is center O? If I take a particle here, let's take P from distance R. So this will also here path, this will be an angle. Same way, if I take particle P here, same way it will follow P1, P dash, anything if I take like P double dash, X, Y, Z, any values. In circular path, the radius of that or distance, it is uniform. They all are in simple harmonic motion. They follow simple harmonic motion in short. If you take any point, like they follow simple harmonic motion. That's what we can conclude here. So same as usual, X of t, a cos omega t plus phi. What is omega t plus phi? What is omega t plus phi? Yes, just now we saw. What is omega t plus phi? Forgot? See here. What is omega t plus phi? That is, what do you see here? Phase. Omega t plus phi is phase. Omega is, what happened if you are feeling sleepy?
Oh no, sir, it's very noisy in my house.
Achha. Okay. So here, whatever angle it is, that is omega. This one, phase. Okay. Now, velocity and acceleration in SHM. So this we saw as omega t. So if I draw one more shape here, wait. From here, at some point P, so this vertical angle, which is making, that is omega t plus 5. This is also omega t plus phi. And perpendicular to that, perpendicular to this one, not this one, wait, let me erase that. This point perpendicular. Okay, so this is what 90 minus omega t plus 5. 90 minus remaining term. Total is 90. So 90 minus remaining term. And out in this one, how I got these values?
Yes, sir. Could you
Yes?
explain again? Could you explain again?
Yeah. So this was omega t plus 5. Okay, so alternate interior angle. These two are this. Let me change color. This one and this are alternate interior angle. It's as it is Z. So perpendicular line from this one. I'm drawing a perpendicular line for velocity. This line to perpendicular to this one. So remaining angle. This total is 90. Total is 90. So this remaining angle is 90 minus. Let's assume this as a x. 90 minus x. This perpendicular angle, why we are considering here for velocity. That velocity is perpendicular to this one. If this object is moving this direction, as we saw in rotational motion, if we draw a perpendicular line, the direction of that shows, or tangent of that shows, that particle shows the direction of velocity. So it is in perpendicular to that object. Is it clear or something wrong?
No, sir. Understood.
Understood? Okay. Take it. So acceleration and velocity. Let's derive for acceleration and velocity. So we wrote v equals to, or that velocity v equals to v cos theta. So here theta is 90 minus omega t plus x. So let me use bracket because we have inside small bracket. 90 minus omega t plus phi. And vertical component v sine, or if we say cos 90 minus theta is v sine theta. Theta is here omega t plus 5. Omega t plus 5 from here. V cos 90 minus theta is v sin theta. It's minus sin theta, right? Cos 90 minus theta is minus sin theta, na? V for t equals to minus v sin omega t plus 5. Okay. So now v is velocity, omega is angular velocity. Omega is angular velocity. So what is the relation between them? V equals to omega r. So r is the positional vector or distance or amplitude. Here we'll take amplitude. So v equals to omega r. So a relation between linear velocity and angular velocity is v equals to omega r. So remember this relation. Wherever we have to find relation between linear and angular, we will multiply with r. R is the positional vector. So minus omega, here we have R as A, amplitude, sine omega t plus 5. To find displacement, let's find displacement. X of t equals to A cos omega t plus 5, which we used already. So as we know, velocity equals to dx by dt. So d by dx, differentiation of this term. So you know differentiation? Cos x as sin x, right? You know differentiation, right? Yes or no? So A as constant. Now cos omega t plus 5, which is minus sine omega t plus 5. Now we need to differentiate inside terms. Omega t. We differentiate this whole term. See. Okay, wait a second. Let me go and see. Okay. Can you hear me, right?
Yes, sir.
Okay. So we differentiated this term. See, this is cos theta. Differentiation is minus sin theta. Fine. But theta is a function of omega t plus 5. So now we need to differentiate theta also. It is a function now because it is in theta we have omega t plus 5. So if we differentiate with respect to t, what will get? Omega as constant, dt by dt, this will be equals to 1 plus 0. Differentiation of phi is 0. It's constant term. So we will get one more omega. So let me erase this. You know formula, or you need to write this formula? You know formulas? This formula? Sine function? Or shall I write formula here?
Yes, sir. Could you write it?
Yeah. So differentiation of cos x is sin x. D by dx. So here omega t we need to differentiate now. Second part, this one done. First, how we'll start this differentiation? First, we'll differentiate this. We'll write as it is. Now we will differentiate inside term. If there is a t here, then we'll differentiate this also. But there is no term of t. So remember, in differentiation we are reducing. In integration we are increasing. Remember this way. So it is n minus 1. N into n minus 1. So n is 1 here. So 1 minus 1, 0. So anything to the power 0 is 1. So we will get minus a omega sine omega t plus 5. Any doubt in this one?
Sir, could you just explain overall just one more time?
Yeah, sure. Understand this clearly, okay? I will explain you one more time, no problem. I can explain you second time or third time or whatever it is. Because next, acceleration, I will ask you to solve. I'll solve for velocity, you have to solve for acceleration. That's why I understand this clearly. Until you get it thorough, you keep asking me. I'll erase this again. So what we are finding, we know as we studied in like kinematics, dx by dt, differentiation of x by dt, that is distance by time. Velocity is distance by time. So x, what is x we have? D by dt a cos omega t plus 5. Okay. So a, when we are differentiating this one, a will be act as a constant. So a as it is. A will be constant. So differentiation of cos omega t plus 5. So this term will act as a cos theta. So differentiation of dt. So this will be differentiation of cos x is minus sin x or sin theta. Theta or x, whatever we are adding, it's a constant term. So if we differentiate this one, it will be a sin x. What is x here? Omega t plus 5. Now we have minus sign here as it is. Now we differentiate this one, but there is inside, we have something inside as t. So we cannot leave this alone. So we need to differentiate inside term, that is omega t plus 5, differentiation of this one. So this will be act as a constant omega, like d by dt omega t plus d by dt of 5. So this will be 0. This will be omega, because what's the differentiation of t n minus 1 n. So n is here 1. So 1 into t 1 minus 1, which is t equals to 0, which is 1. So this whole term will be 1 into, there is one more constant, that is omega. So it will be into omega. So we have to write omega there. That's it. Is it clear?
Just the differentiation bit from after cos.
So you're not able to understand differentiation.
Some bits I get lost, sir.
Okay. This is actually differentiation of some function. So okay, let me see here some other way. You're not able to understand this one, then let me write stepwise. Cos x d by dx. Differentiation of cos x is minus sin x. This one first step clear? This is a formula.
Okay, sir.
So that's what we did here. Now this here we are considering omega t plus 5 equals to x. We are considering here x. x or a or any variable. This is just variable. X is here variable, not this distance. This is separate. Okay. This is what we are doing. It is separate. We are considering x as a omega t plus 5. Now we differentiated this one. So we got minus sine x. This is your first step. Second step, here sine x is there. Keep it as it is. Now in x, what we have? Omega t plus 5. So we need to differentiate this also, because in x we have t terms. X is a function now. It is not just x here. X has t term because we are differentiating with respect to t. D by dt. So this term also we need to differentiate. So we will differentiate this one. So dx by dt, which will be equals to d by dt of omega t plus d by dt of 5. This term is already there. First term is already fixed value. We already got fixed value, which is this one. First term, fixed. Now we are talking about second term, which we wrote here. So this differentiation of this omega t will be 1. That is 1 into omega is omega plus 0. So dx by dt as omega. So we can finally write here minus sine x. X was, what was x? What is x here? See here, what is x?
Omega t plus 5.
Yes. Omega t plus 5 fixed. Now we have one more thing, that is omega. This term from here. So our final form is minus omega sine omega plus 5. Now we already have a there. We already removed a from the differentiation. So we got finally minus a omega sine omega t plus 5. Understood?
Yes, sir.
Clear? 100%?
100%, sir.
What about other? Devanshika?
Yes, I understand.
Okay. Because I'm going to ask you to solve for acceleration. We got this velocity. This was velocity v. So let me box this. Okay. So A equals to dv by dt. So now what you have to do? You differentiate this term d by dt minus a omega sine omega t plus 5. Now I will tell you one hint for this one. Differentiation of sin x is cos x. Only this hint I will give you. Remaining you have to do. Come on, tell me answer here. First. Yes? You got an answer? Yes, Devanshika. Sign Yati. Answer. Finding difficult? Tell me, come on. Is it that long? Yes, sign.
1 second.
Use this formula. You'll get answer. Only one step. Answer is just one step. Come on. Same manner. Ditto same manner. First step, differentiation of this one. Second step, differentiation of this one. First step already wrote here. This is your first step already. Okay, let me just tell me what is the first step answer. Yes, Devanshika?
Sir, will it be like the same of the last, but minus say omega cos omega t plus phi?
Omega cos omega t plus phi, that is correct. But what was omega? What you said before that? A minus a what? I didn't heard that. You said minus a omega cos omega t plus phi. That's what you said?
Yes, sir, that only I wrote.
No, you're saying this one? Okay. But did you differentiate this second part? Omega t plus 5. If we differentiate, what will I get?
One more omega will also come out.
Yeah, so that will be omega square here.
Yeah, I didn't know whether to add or multiply.
No, omega into omega will be omega square.
Okay.
So now I can write this term as a, what are the x? What is x here? How we started, from where we started? A cos omega t plus 5. So I can write this here, minus omega square x of t. Acceleration is similar to minus omega square x of t, because x is a cos omega t plus 5. Right? I'm substituting this one here. Got it? Any doubt in this one?
No, sir.
Okay. Devanshika? Okay. If no doubts, we can end the class.
Okay, sir.
Okay. So next class we'll do remaining things. Energy and all periodic function. You're not writing, right? Finished writing?
Yes, sir, I finished.